Welcome to the Tech Talks podcast, where we dive deep into the latest innovations in technology. Today, we have Dr. Emily Carter, an expert in AI and machine learning, to discuss a fascinating development in large language models. Welcome, Dr. Carter.
Thanks for having me. I'm excited to share some insights with your listeners.
Let's start with the basics. Large language models, or LLMs, are quite the buzz these days. Can you explain what makes them so resource-intensive, especially with long context inputs?
Absolutely. LLMs are designed to process vast amounts of text, and they do this by breaking down input into smaller units called tokens. When these inputs are lengthy, the model needs to process many tokens, which demands significant computational power and memory. This can slow down inference and consume a lot of resources.
That sounds like quite a challenge, but I hear there's a new method called GemFilter that addresses this. Could you tell us more about it?
GemFilter is an innovative approach that leverages the early layers of LLMs to filter out less relevant tokens. Imagine you're reading a book and only highlighting the most important sentences. GemFilter does something similar by using attention matrices to identify and retain only the crucial tokens, reducing the input size for subsequent layers.
That's fascinating. How does this impact the model's performance and efficiency?
By compressing the input early on, GemFilter achieves a 2.4x speedup and reduces GPU memory usage by 30% compared to other methods like SnapKV. This means faster processing times and less strain on computational resources, which is a game changer for deploying LLMs in real-world applications.
Impressive results. Can you give us an example of how this might be applied in a business scenario?
Certainly. Consider a customer service chatbot that needs to understand lengthy customer inquiries. With GemFilter, the chatbot can quickly sift through the text, focusing on the most relevant parts, and respond efficiently without lag. This improves customer experience and reduces operational costs.
It sounds like GemFilter also has broader implications beyond just efficiency. Could you elaborate on that?
Definitely. By using early layer attention matrices, GemFilter not only optimizes performance but also enhances our understanding of how LLMs process information. This insight could guide future improvements in model design, making them even more efficient and interpretable.
That's really insightful. Are there any limitations to this approach?
One challenge is ensuring that the most relevant tokens are accurately identified, especially in complex contexts. However, by focusing on early layers, GemFilter effectively addresses inefficiencies in the prompt computation phase, which is often a major bottleneck.
It's amazing how these advancements can transform AI applications. Any final thoughts on what this means for the future of LLMs?
The development of methods like GemFilter marks a significant step forward in making LLMs more accessible and practical for various industries. As we continue to refine these techniques, we'll likely see even more innovative applications and optimizations in AI.
Thank you, Dr. Carter, for sharing your expertise with us today. It's been a pleasure having you on the show.
Thank you for having me. It's been great discussing these exciting advancements.